Moving average from a data stream looks like it needs a full recomputation each time, but there's a sliding window trick that keeps it big O of 1, constant time per call. You are given a fixed window size and a stream of integers. Each time a new integer arrives you must return the average of the last up to size values. For example, with a window of 3 in the stream 1, 10, 3, 5 the outputs are 1.0, 5.5, 4.666, and 6.0. The challenge is to do this efficiently for a potentially infinite stream. The straightforward way is to keep a queue of the last size elements, and on every call sum the entire queue to compute the average. That works but costs O, size, time per call because you iterate over the whole window, and O, size, space for the queue. If the window is large or the stream is fast, that linear scan becomes a bottleneck. The key insight is to maintain a running sum of the window so you never have to resum. When the window is full, you subtract the element that falls out, add the new element, and divide by the current count. In code terms you keep a queue and a double sum. On each new value, if the queue already holds size items you dequeue the oldest and subtract it from the sum. Then you enqueue the new value and add it to the sum. Finally you return sum divided by the queue's current length. Let's trace the optimal method with size 3 in the stream 1, 10, 3, 5. Start with an empty queue and sum 0. First value 1, queue becomes 1, sum is 1, count 1, average 1.0. Second value 10, queue, 1, 10, sum 11, count 2, average 5.5. Third value 3, queue, 1, 10, 3, sum 14, count 3, average 4.666. Fourth value 5, queue is full so we dequeue 1, subtract it from sum, 1 4 1 equals 13, and queue 5, added, 13 plus 5 is equal to 18, queue now, 10 3 5, count stays 3, average 6.0. Matches the expected output. You'll recognize this pattern whenever you need a running statistic over a fixed size recent window, think moving sums, moving minimums, or any sliding window aggregate. Time complexity is big O of 1, constant time per call because each operation does constant work. Space complexity is O, size, for the queue that holds at most the window elements. Try the next problem, same sliding window pattern. Subscribe for more pattern-focused DSA walkthroughs.